Hi, my name is Frank, and before I start talking about my project, I'm going to give you a brief overview of it, the business logic behind it. And this is, energy demand forecasting, and it deals with utility companies and energy consumption. This comes in the sense of, every time we flip a switch, charge our phone, or put on the AC or heater, there's something happening behind the scene that deals with electric being consumed. Now that is in the sense of electricity can't be stored in bulk like fuel or other things can be stored. It's only generated instantly at the moment we use it. So in that sense, okay, data is being needed for these utility companies to know at what rate to produce. So that is, they do not overproduce in the terms of wasting megawatts, raising costs, or even hurting the environment. And they do not underproduce, which leads to blackout outages, or even perhaps angry customers. So now, this is how this project is being inspired by our mentor that gave us this to work on. So it's actually based on we getting data from NOAA API and EIA API to get temperature data and energy data, and then compare it together so that utility companies can know at can be able to foretell or make decision at what days or during season that they can produce amount of energy to their customers. Okay, because yeah, we all know that there are many things that can influence energy consumption, such as maybe season, weather. Sometimes it can be on probably during celebrations or weekend, but mostly this is being focused on weather. So this is the main entry file. This is the main function of the code that fetches weather data from here and energy data from the side. And this year, okay, this year is the URL, and being having created my gotten my API key, I was able to get the um data I need using I am putting it in the parameters, and this also goes to the same thing with the energy data. uh these are the parameters that I added, got the energy consumption for the day, put in the city. The project I worked on is based on five cities: Chicago, Houston, Phoenix, New York, and what's the other city? Okay. Okay, yeah, these are the cities. Seattle. So then all this thing is being gotten, filtered, and removing the missing values so that it will not disrupt the data, clean it and save it into a CSV file, and then use the pandas library data frame to be able to structure it and then create the visualization out of it, which is what I'm going to show in a moment. But these are just the files. I don't want to spend much time on this. These are just this file that makes up the project. And here, okay, if I were to go to if I were to run this streamlit, okay, it's going to go like this. Streamlit. Okay, it's actually going to bring up the visualization and everything. And okay, here's it. Bam, booyakasha. And this is just the visualization I made based on the data I got from the weather of each cities and the energy that was consumed, okay, for the day, and it can be filtered by weeks and months. So basically, here is the data for the visualization data for geographical overview for Chicago. Okay, you can we know that, yeah, the bubble side indicates the amount of energy used, and the bigger the bubble, the amount of energy that is being used. Energy intensity, sorry. So yeah, and this here goes with the temperature versus energy consumption. Okay, and well, this is just for the all cities, and it can be filtered down to New York. It's loading. Then okay, we can see this highlighted gray is the part for weekends. You can see how, okay, the energy and the temperature is being displayed. Okay, that gives us a, typical knowledge of how energy influences, temperature influences the uses of energy. And this is here the correlation analysis, where different colors indicate different cities, and then the x-axis is the average temperature, and the y-axis is the energy consumption. So this is for monthly trends. I think extremely doesn't really works for the time range of monthly. It only works for weeks and days.